This meeting is being recorded.
Problem 16 from Chapter 1 asks us to identify electron configurations, but not for neutral atoms. We're asked to do this for ions now. So for A, we're told, or asked rather, that we have a carbon atom with a negative charge. So we want to consider neutral carbon first. So we know that that's 1s2, 2s2, 2p2, 2p2 for the last orbital. And with a negative charge, we would add an electron. So our carbon with a negative charge, a carbanion, would have 1s2, 2s2, 2p3. And then for B, we're going to do something similar. We're going to start with 1s2, 2s2, 2p2 for a neutral carbon atom. But now we're going to remove an electron. So we would end up with 1s2, 2s2, 2p1 for a carbon with a positive charge. So let's take a look at the periodic table. So we'll check out nitrogen and oxygen. So nitrogen has 7 electrons, oxygen has 8. So let's use that information to figure out the electron configuration of our nitrogen with a positive charge. So we're going to go from 7 electrons to 6. And then our oxygen, we have 8 to 9. So for the nitrogen, we're going to have 1s2, 2s2, and then we would normally have 2p3. We have 2p2. Right, so this would be nitrogen with a positive charge. And then for D, we've gone down or gone up, right? We have a negative charge on our oxygen. So we've gone from 8 electrons in a neutral oxygen up to 9. So that would be 1s2, 2s2. That takes care of 4. And then 2p5 would be the electron configuration for an oxygen with a negative charge.